Okay, so we're going to talk about section 11.1, part 1 today. That begins on 688. And we're talking about what the book refers to as the basic equations. And so what we're really talking about in this chapter is really kind of the heart of analysis in mathematics. So we're going to be looking at the relationship between graphs and equations. And in particular, what we're really going to be looking at in this chapter is conic sections. We'll talk more about that when we move on to section 11.2. So what we're talking about with the basic equations is the set of equations listed on page 688, distance formula, equation of a circle, slope of a line, point slope formula, slope-intercept formula, parallel slopes, perpendicular slopes, midpoint formula. That whole list of things. These are equations that you guys have learned, you guys have used for years, you guys are expected to know. If for some reason you are rusty and don't remember how to work with these, you need to brush up on them. Okay, there's not really an excuse for that because you guys have worked with these for now 4 years in a row minimum. This is the 4th year. So you did it in algebra for sure. You may have seen it in pre-algebra, at least some of it. Did it in algebra, you redid it in geometry, you did it again last year in algebra 2, and we talked about these things earlier on in the year in math analysis. Okay. I'm not going to go through how to use the basic formulas. What we're going to do is I'll just show you a couple of examples of some of the things they're going to ask you to do to kind of refresh your memory and shake some of those cobwebs out. Okay, so the first example I want to do for you is to find the equation of the line in slope-intercept form that passes through to -5 and 4, 2. All right. So first of all, slope-intercept form is y equals mx plus b, where m is your slope, b is your y-intercept. And what we're going to do is we're going to go through this problem just using y equals mx plus b. So my recommendation is start by writing down y equals mx plus b. Like I remind you guys all the time, and it's going to be very important in this chapter, start by writing down the general form of your equation. That way you always can keep your eye on the prize. You know what you're aiming for. Our job is to replace m and b with the proper values. The next thing we're going to do is we're going to find m. And in order to find m, we have to look at the information given to us. They did not tell us the slope, but we know how to find the slope through 2 points. And that's our slope formula, y2 minus y1 over x2 minus x1. So this is our x1, y1. x2, y2. Make sure you're doing the y's over the x's. Remember that slope is rise over run, not run over rise. Rise goes vertically, run goes horizontally. So the y values, since they are the vertical values, have to go on the top. So we have y2 minus y1 over x2 minus x1. Use parentheses when you plug in. This becomes 7 on the top and 2 on the bottom. So there's our slope. We can now plug our slope in. Y equals 7/2 x plus b. Now, in order to find our y-intercept, our b, what we're going to do is we're going to pick one of our 2 points and use it. I'm going to choose this one, but it doesn't make any difference. They both have to work in the equation, so we can use either one of them to find the missing value in our equation. So we're going to plug the 4 and the 2 in for our x and our y. So we know that y is equal to m times x plus b. So 2 is equal to 28 over 2, which is 14 plus b, which makes b equal to -12. And so we now know that this equation is y equals 7/2 x minus 12. There's the equation of the line passing through those 2 points in slope-intercept form. Okay, again, very simple. It's an Algebra 1 problem. But this is the way it works, just to refresh your memory. Okay, what we're now going to do is we're going to take a look at a variation on that where we get different information, but again, we have to find the equation of the line in slope-intercept form. So now, again, we want slope-intercept form, but now we want it to pass through the point 3, 5. Sorry, that looks like an 8, not a 5. Let's fix that. 3, 5, and is perpendicular to the line 2x minus 3y minus 1 equals 0. Okay, there's a couple of different ways that you can attack this problem. I'll show you a couple of different ways to do it. You can pick which way you prefer. Since we are being asked for this in slope-intercept form, I'm going to do it one time the whole way through in slope-intercept form. I'm also going to show you how to do it in point-slope form and then change it at the end to slope-intercept form. That's another option. So we're going to start with y equals mx plus b. Our slope is equal to, and they do not tell us our slope again, and they do not give us 2 points. So the question is, how do we find our slope? Well, the clue to the slope is this right here. We know that our line is going to be perpendicular to this line, and we know from Algebra 1 that the slopes of perpendicular lines are opposite reciprocals of each other. They are both opposite and reciprocals. So if I find the slope of this one, I know what our slope is going to be. So the first thing I'm going to do is put this into slope-intercept form. In other words, get y by itself. So those cancel, and we get negative 3y equals negative 2x plus 1. We're going to divide everything by negative 3. And we get y is equal to positive 2/3 x minus 1/3. We don't care about the y-intercept because that's the y-intercept of this line. It has no bearing on the y-intercept of our line. All we care about is the slope, the number in front of x. So the slope of this line is equal to 2/3. So therefore, the slope of our line is going to be equal to negative 3/2, since they're perpendicular. It's the opposite reciprocal. So we go from positive to negative, and we go from 2/3 to 3/2. Now we can plug that in. Y is equal to negative 3/2 x plus b. And now again, just like in the last problem, we're going to use the point that we know to fill in our missing value. So we know that 5 is equal to negative 3/2 times x plus b. So 5 is equal to negative 9/2. Remember, this is 3/1, not 3/3. We're going to add 9/2 to both sides. B is equal to, you get a common denominator. This is really 10/2 plus 9/2 is 19/2. And so this equation then is y equals negative 3/2 x plus 19/2. There's our equation in slope-intercept form through that point perpendicular to that line. Now, the other way to go about doing this, once we find the slope and we have our point, 3, 5, we can actually use point-slope form. So let me show you how to finish this out with point-slope form. So let me grab this. Actually, I don't need to copy it. I'm just going to go to a new screen. Okay, so we know that our point is 3, 2. I'm sorry, 3, 5, excuse me. 3, 5. And we know that our slope came out to be negative 3/2. I knew we had a 2 in there somewhere. Okay, If you know the slope of a line and you know one point that's on the line, you can use point-slope form. Now, we still need to get our final answer in slope-intercept form because that's what we were asked, but we can use point-slope form to get there. Point-slope form says that y minus y1 is equal to m times x minus x1, where the x1, y1 come from your point, and the m is obviously your slope. The regular y and regular x stay regular y and regular x. Those are our variables in our equation. So, plugging in, we get y minus y1 is equal to m, again I'm using parentheses to plug in, times x minus x1. And so we get y minus 5 is equal to, if I distribute this, I get negative 3/2 x plus 9 over 2. Now to put this into, again, we're putting this into slope-intercept form. Otherwise, I could have left it in this form just without the extra parentheses. We add 5 to both sides to get y by itself for y equals mx plus b. And we get y is equal to negative 3/2 x. Again, this becomes 10 over 2 to get a common denominator, plus 19 over 2. So again, we get the same equation we got the last time. Just a different way of getting there. You're welcome to use either one. It makes no difference to me. Whatever you're more comfortable with is all good. Now, the other thing I want to talk to you guys about is I want to talk to you guys about standard form. So let me copy this real quick. Put this on a new screen. What they can do sometimes is they might ask you to find the equation of the line in standard form. Standard form of a line in our book is ax plus by plus c equals 0. Remember, in Algebra 2, it was ax plus by equals c, where the constant number was on the other side. In our book, that's not the case. Everything's on one side. You have a 0 on the other side. There are a couple of conditions for standard form. Number one, everything's on the left, x and then y, and then constant equals 0. Also, no fractions, and a must be greater than 0. A should be a positive number, otherwise we need to make it positive. We don't care about b and c being positive or negative, but a should be positive. So, if they ask you to do the same problem we just did two ways in standard form, you don't do the problem in standard form. You can, but it's a roundabout way to do it. It's much easier to just do it this way and then change it into standard form at the very end, which is very easy. So what we do to do this into standard form is the first thing we do is we take care of the no fractions. I multiply both sides by 2, or whatever my common denominator is, and that kills off the fractions. Now I need to move everything to the left, so I'm going to add 3x to both sides and subtract 19 from both sides. Those are gone, and I get my 0. Here I have x first, and then y, and then my constant. Notice that a is already a positive number. If this was negative 3, you would multiply everything on both sides of the equation by negative 1, and that would change it into a positive. There was no need for that on this particular problem. So now this is the answer in standard form. All right. The last thing that I want to talk to you about on this particular part of this section is the basic equation of a circle, because you're going to have some circle problems on the assignment. This is actually the first of our conic sections. We'll talk more about that, like I said, in the next section, not the next video, but the next section. But for right now, let's just go back to what you learned in geometry about circles, and that is that for a circle with center having coordinates h comma k and radius equal to some value r, the general equation of the circle is x minus h squared plus y minus k squared equals r squared. You've got to know this formula, just like the other basic equations. So for example, if we have a center of -2, 1 and a radius of 5, you would plug this in. This is your h, this is your k, this is your r. Notice there's a negative built into the formula in front of h and k, which means that when we look at the equation, h and k will end up looking like the opposite of what they actually are. That's going to become a very important concept when we're working with conic sections throughout this chapter, because we move them all around away from the origin 0, 0 the same way using h and k. So x minus -2 squared plus y minus 1 squared equals 5 squared. This becomes x plus 2 squared. This is y minus 1 squared. This is 25. That's the equation of the circle given that information. Notice that h looks or appears to be the opposite of what it actually is. K appears to be the opposite of what it actually is. Now, likewise, they could give you an equation. They could give you an equation like x minus 3 squared plus y plus 2 squared equals 16. This tells us that our center, it looks like -3, but it's really +3 because it's x minus h, so h is 3. And this is y minus k, so k must be -2. So there's our center, and our radius is the square root of 16, since that's r squared, which is 4. Now, as far as graphing these go, graphing these is very simple. To graph these, we just use the center and the radius in order to graph. So the center is 3, -2. The radius is 4. So we have our center at 3, -2, which is right here. And we're going to go 1, 2, 3, 4 to the right, 1, 2, 3, 4 to the left, 1, 2, 3, 4 up, 1, 2, 3, 4 down. We don't know exactly where 4 is diagonally, so we don't worry about it. We use our guide points, and then your job is to sketch this in as a nice circle. It needs to be circular as possible. It does not need to be perfect, but make sure it doesn't cave in on itself. Make sure it doesn't have any straight pieces on it, and make sure it touches all 4 of your guide points. That's extremely important. Okay, if you don't put any effort into making it look relatively circular, and you don't put any effort into hitting those guide points, then I'm going to dock you points on the quiz and the test. Okay? But other than that, I'm not a big stickler about it. All right, so I'm going to cheat a little bit here and to draw mine in, since it's a little bit difficult sometimes to draw on the screen. There's our circle. Now, the last thing I want to point out to you very briefly is that sometimes you're going to have problems that talk about the tangent line to a circle at a particular point. Okay? And when you are working with the tangent line to a circle at a particular point, I want you guys to just remember from geometry that if you have a tangent line to a circle at a particular point, so let's say that point is right there, remember that the radius drawn to that same point of tangency, I'm sorry, I still have my vectors from the last chapter. Let's get rid of our vector symbol. There we go. There's our radius. Remember that the radius is perpendicular to the tangent line at that point. That comes from geometry. That means that if you know the slope of the radius line, then you know the slope of the tangent line, because their slopes are opposite reciprocals. So you can find the slope, and if you know this point, then you have a point and the slope. You can use point-slope form or slope-intercept form to find the equation of the tangent line. All right, so that's the initial introduction to section 11.1. We have one more day on section 11.1, so make sure you watch the video also for 11.1.2, and then we're going to launch into our conic sections.